Hello, IM3 students. Today we are going to learn 13.1 day 3, which is the last day of exponential growth function. So we're going to wrap it up by taking a look at how the problems can be modeled with real-world situations dealing with exponential growth function. So as you know, there are many types of problems in the real world that deals with exponential growth, like anything that kind of gains value, like your house, the value would go up. Like the money in your bank should, earn interest, so the value should go up. Like something that is valuable, like stock could go up, right? The value. So there are many, many examples. So here is an equation that is important. Exponential growth function, specifically dealing with like the growth value. So we have f of t, the function in terms of time, t for time, is equal to a, the initial value, times 1 plus the ratio. So the ratio, 1 plus r right here in this case, the parenthesis, is considered a growth factor. So basically it's like explaining how fast is the value of your house growing, or how fast is your money in the bank account growing. So this is a growth factor. So it is always 1 to stand for 100% of, basically the base value of your home or your bank account. That's kind of like, whatever your money you put down. And then R is like how fast is the rate growing. So let's say it's growing 5%, you're getting like basically 105%, because you need the 100% plus the 5%, right? It's earning, so you should have more than 100%. It's like, and also it's like saying, if you're buying an item in the store, you have to pay 100% for the price of that item that you're buying, plus another 10% or whatever the percent is for the tax. So you're actually paying more than 100% for that item. So it's almost the same concept here. So this factor is called the growth factor. So we're going to be using that to estimate the function, the growth rate. So to see how fast your money is growing, what is your balance going to be after a certain time. So that's the formula we're going to be using. Here's an example. Eileen has 2 investments that she purchased at the same time. Investment A costs $10,000 and earns 4% interest each year. Investment B costs $8,000 and earns 6% interest each year. So part A says write a function that corresponds to each investment and use f of t for investment A and g of t for investment B. So for f of t, the first function, we can use this formula that we just learned, which is a, the initial value, and in this case, so let's just write down the formula. A times 1 plus r to the t power. So substituting the initial value is 10,000 times 1 plus the ratio that is growing is 4%, so it's 0.04, and then to the t power. And of course, we can simplify this to 1.04 if we wanted to. So that would be 1.04 to the t. Now g of t, the second investment, is going to be the same thing. And instead of 10,000, it's going to be 8,000 times 1 plus the ratio is 0.06 to the t power. And if we want to simplify that, we will have 8,000 times 1.06 to the t power. Okay, so those are the 2 investments. This is investment A and this is investment B. Now, part B says find the value of each investment after 5 years. So we're going to evaluate basically f of 5 and g of 5. So we're going to substitute 5 into the function. So this will be 10,000 times 1.04 to the 5th power, which you should get approximately 12,166.53 cents after 5 years. And then the second investment is 8,000 times 1.06 to the 5th power, and that should give you approximately $10,705.80 for the 2 investments after 5 years. And question C, part C says, explain why the difference between their values, which was initially $2,000. So originally between $10,000 and $8,000, there is a $2,000 difference. But now if you look at 5 years later, the difference between those two is actually, when you subtract the two, should be 1,460.73 cents. So explain how come originally they had a 2,000 difference. When you subtract 10,000 minus 8,000, you get 2,000, right? But now you subtract the balance, it's less than 2,000. Well, the reason why is because one of the account is earning more interest, the second account is earning higher interest. So your money is actually getting more interest. So therefore, that kind of like catches up to the first investment. So that is the reason why so investment B is earning more interest, and that's the reason why. So that answers that question. Let's take a look at the next question. This is a triad problem, so you need to pause this and try the problem before you go on. Use the formula that we just learned today. The annual sales of a fast food restaurant are 650,000 and are increasing at a rate of 4% per year. Write the function f of n that expresses the annual sales after n years. So f of n is equal to initial value. Again, we're going to use a times 1 plus r to the t, which is 650,000 times 1 plus growing rate is 0.04% to the nth power. So this would be the formula. And then find the annual sales after 5 years. So basically we're looking for f of 5, which is 650,000 times 1.04 to the fifth power. So that should approximately be $790,824 with 39 cents. So this is going to be the sales after 5 years. Example 2. Johnny researches a baseball card and finds that it is currently worth $3.25. However, it is supposed to increase at an 11% per year. Well, that's a big increase. In how many years will the card be worth $26? So if we start with f of t, the function is equal to initial value, which is $3.25, times 1 plus the increase rate is 0.11 to the t power. And since we already know we want the value to be at $26, so I'm going to let f of t be $26 and then find out how many years it's going to take the equation. We can combine the 1 plus 0.11 here, and then here we're going to use the graphing calculator. But before we do that, let me make the equation. So we can go ahead and let y, one of the equation be y equals 26, and the other equation be y equals 3.25 times 1.11 to the t power. So I'm going to go ahead and use my graphing calculator here and enter into the equations. So I have y equals 26. That's my first equation. And the next equation, I'm going to enter y equals 3.25 times 1.11 to the x power. So that's my second equation. And notice that where they meet, that is going to be where the x value is going to be. So you see that y value is 26. That's the second equation. So at x equals 19.9, which is approximately 20 years later, that's when the baseball card is going to be worth $26. So that is how you can use decimals to solve this problem. And let's take a look at our answer. So we know that the answer is x is approximately 20 years. So after 20 years, the baseball card will be worth about $26. And that is the end of this problem. So you're going to go ahead and try one on your own, and you can go ahead and use decimals to help you to solve the problem just like we did earlier. So go ahead and pause and try it. Hopefully you've had a chance to try the problem. Let's read the problem. A certain stock opens with a price of 0.59 Over the first 3 days, the value of the stock increased an average of 50% per day. If this trend continues, how many days will it take for the stock to be $6 worth? So just like the last problem, we're going to set the problem of f of t is equal to initial value of 59 cents times 1 plus, wow, 50% per day. That's a very, very hefty increase. So 0.5 to the t power. But we want to know when this stock will be worth $6. So we're going to let it be $6. And then same thing, combine, it's going to be 1.5 to the t power. I'm going to use the graphing calculator again and let one side equal to 6 and the other side equals to this equation here. So here we go again, graphing calculator time. And we're going to change the value this time to 6. And the second equation is going to be y equals 0.59 times 1.5 to the x. And again, these two graphs meet right there on that dot. So x is about 5.72, but we cannot say, hey, after 5.72 days later. So we're going to just say approximately x is going to equal to approximately, or not x, t is approximately 6 days. So it's going to take 6 days for the stock to be going up to from 59 cents to $6, which is incredibly short time. And that is the end of the problem and also the end of the lesson. So you may go ahead and get started with your Google Classroom assignment, and I will see you next time. Bye.